I just say hi, and it says, how can I assist you with plumbing services? It's gonna say it's residential. So it says the estimate cost is 150, and it's also asking, would you like to submit a service request to our team? Yes. Make sure to provide full name, phone number, and email address. So I just give it this information, and it says that it's successfully submitted. Hello and welcome to this video. Today we are gonna learn how to deploy your AI app or AI agent using AWS and Python. And I'm not kidding when I'm saying you can charge 3,000, 5,000 or 10,000 for this AI agent, because we built it step by step. If you didn't watch previous videos, what we did is we started by building the knowledge base based on your PDFs. We then save leads to the CRM. And today what you're gonna learn is how to build a scalable API using FastAPI and Python. We are gonna use the serverless framework and Docker to deploy everything. Then we are gonna deploy our AI application and RAG to AWS Lambda. And after that, we are gonna create a little chat widget that can sit on our website and answer user queries 24/7. So let's get started. The skills that you are gonna learn in this video is Python, LangChain, Pydantic AI, Airtable, OpenAI, function tools, ChromaDB for the vector store, how to build a knowledge base, FastAPI, Docker, AWS Lambda, serverless framework, and how to use VoiceFlow. I recommend you watch these 4 videos before diving into this one, because we built the RAG, we turned it into a chatbot, and now for this video is how we deploy this on our website and actually let people use it. So these 2 videos will give you context on what we are building today. Now let's start with a quick demo. So I created this fiction business and fiction website. FlowFix is a plumbing services that provides plumbing services, and we have some nice website. Now here we have the chatbot that we are gonna create in this video. I just say hi, and it says, how can I assist you with plumbing services? It's gonna say it's residential. So it says the estimate cost is 150. This is not the final cost. And it's also asking, would you like to submit a service request to our team? Yes. Make sure to provide full name, phone number, and email address. So I just give it this information, and it says that it's successfully submitted. Let's check our CRM, and we see now a new row, and we also see that we didn't mention the description, but it inferred it from our chat. So pretty cool, right? We have a chatbot that is answering questions from a knowledge base and also integrated in our website and also saving leads to our CRM. How powerful is that? And it can run 24/7. It can generate leads, whatever, right? Pretty cool. So up until this moment, we built our agent. Okay, so previous videos, we have the RAG and we also have the agent. If I'll give you a quick recap, this is what we did in the previous video. So before we had this agent that had a system prompt, LLM, memory, and tools. One of the tools was being able to save to the CRM, giving more detailed cost estimate, and also answering questions. This answering questions came from our vector store, and the way it works is we took a PDF, we divided 2 parts, and then we embedded it. We embedded it with embedding function. So essentially we took our text from the PDF, turned it into vectors, numbers. We then stored it in our vector store, which is ChromaDB for this case. And then when the user is asking a question, like we saw in the demo, it's taking the user query. It's also turning it into numbers to this vector. And then it's calculating the distance between the vectors in our DB and the vector of the user query. And it's trying to find the most similar in distance and in context, in meaning documents. We then connected on top of it the LLM to package it well so it can answer the question. Then we connected this knowledge base, this query knowledge base. We connected it to our agent, and this is what we got in the previous video. And we saw that we can test it on the terminal, and it worked. But now we want to make it usable for users. So this is what we are doing today. So the first thing we are doing is we, first of all, restructure the application a little bit, because the center of the app before was the agent. Now it's changing a little bit and we need to restructure it. So we have these Python files that where the agent is living, all this logic here. And then on top of it, we need a way to connect it to the outside world. The way we do this is we need to connect it to an API. We are using FastAPI for this. And then we're using Docker. So Docker, we'll dive into what is Docker and so on. but we are creating kind of an image, a package of all our agent, including the API. We deploy this to AWS Lambda, which is a serverless cloud function, meaning we don't need any server, we don't need to manage the server. It's running 24/7 and they are handling this for us. And then we are exposing this API gateway so our voice flow chat widget can access our API gateway. We are going to use serverless to do all the deployment stuff. So once users are coming to our website, they see our widget, ask questions, we transfer the user query to our application, to our chatbot, to our agent. The agent is handling the user query, whether it's using the tools, answering questions, whatever it is, and is getting back the response to the voice flow widget, and the user can see that. So now we are going to dive into each one of these and we're going to build them step by step. So to actually deploy this thing, we need to do 3 stages. The first one is to make the agent handle multiple chats. Then we want to connect it to an API. Then we want to deploy this to AWS Lambda and connect it to the website, embed it in the website. And you have the link below to the whole code base. What you want to do is you want to clone this. You want to create a virtual environment. You want to activate it and install your requirements. And you have this little file that has these 3 environment variables. You want to set them up. And you also have instructions on where to get these keys from. The first thing to do is to build the AI agent. First, we build the vector store. What it's doing, it's taking all the files that are in the resources docs. In this case, we have this knowledge base. This has some simple details about the business, pricing, everything you need to know about the business. Building this just creates this vector store and storing everything on our ChromaDB SQLite. Then you can test this by querying the RAG using this command, and then you can run the agent. Now, this is the changes we did first. So we moved the agent from our main file to this agent file, and here what's happening is we moved it to a function, just doing some refactoring. Then we create our agent here, and now this is how we support multiple chats. Now, this is a very simple implementation. What you want to do in real life in production is to store these chat histories in some kind of a database, and you want to think about this further, but here is just simply saving all the chat histories per user ID on this dictionary. So we created this function that is going to handle all the chats. So it's getting the user ID and message, and if there is no already chat history, it's going to initialize it with a new array, with a new list. If there is already an history, it's going to pull it, and it's going to do the request to our agent with a message from the user, and also if there is history existing, it will send the history. Then we take all the messages after we got the response and we store it back to our dictionary and return the response. That's all we do. And again, if you need more explanations on how this agent is working, you need to watch the previous video. To test this, we're gonna uncomment this one, and we're gonna go to the docs here and just run this. And what we see is that we got a response from our agent. Next, we want to connect our agent to an API, so then we can do some API requests and it will get to our agent. The way we do this is we created this API.py file, and here we create a FastAPI application. We give it a name, we give it we're handling the cores here. And if you want to add some security, you want to put your website in here. So then it will make sure that only your website can make calls to this API. We then give it some health endpoint just for testing, and we'll dive into this one in a moment. Let's go back to the README file. We run our API, and we see that we got it in our local host and 3030 port. And by the way, this port is coming from our settings. So if you want to change this, you can go to settings. Here we're using a cool library called Pydantic settings, which just takes all the environment variables and load this to this class. If you put the right names, it will automatically load it, which is pretty cool. So you can either change your port here, or you can go to the sample and change it here. Great, now that our server is running, we're gonna do some health check. We see that we got the status okay, and now we want to call our agent. So let's explain in a moment what's happening here. So we get the query and user ID from the endpoint. If there is no query, we return 400 status code, and then we just call the function from before that is doing all the handling, pulling the history and so on. we get the response and send back the response. Let's test this. Hey, how can I assist you? If I do, for example, number 2. So now we can manage multiple chats from our API. Okay, so that was the easy part. Now we need to expose our API to some cloud service. In this case, we are using AWS, and now where the deployment comes in. So we are gonna use Docker. We're not gonna dive into this. I'm gonna put a link below. You can dive into this later. But Docker is a really powerful tool that allows us to take our application, take our agent, create kind of a package, which in Docker terms, it's called Docker image. So we take this image of our agent and we can install it anywhere we want on the cloud and it will still work. So we are gonna build this image of our agent locally. And the cool thing with Docker is that we can then install it on our AWS Lambda. If you have different servers, you can install it over there, and it's gonna work consistently across these two platforms. If you're not using Docker or you're used to some other tools, what essentially you'll do, it will work on your local machine. Then when you deploy this, there will be some sorts of issues. It will not be consistent, and you need to figure out how to deploy it in this different environment. So really, Docker saves us all this time, and recently it became my favorite tool because it's just easy to use and it works really well. Okay, now the way we define our Docker image is with the Docker file. So the Docker file is basically all the instructions and what this image should do. So the first thing is we start from this base image, and this image is coming from AWS and it's specifically designed for Lambda. So this makes our life much easier. And when we build this locally, it will be so easy to deploy this to the Lambda. We then copy our requirements.txt to the Lambda task root. And this environment variable is coming from this image. So it's defined as var task. And this is basically our working directory. This is where all our code, all our application is gonna be. Let's ignore this one. We then install the requirements on the image. We expose the port. Let's ignore this one. And then we copy all our files, and we also concatenate to our Python path. So when we call different files inside our project, it will still work. And then we call this command. After we define our image, it's time to build the image itself, right? We are gonna use the docker build command, and this is what's happening here. So before we even build the image, we wanna make sure that our vector DB is updated. So we do this one. Let's say, for example, we added documents, we added more knowledge base, case studies, whatever. We wanna make sure that every time we deploy, every time we publish this to our clients, to our users, it's always updated. Then we want to log in to the registry of AWS. So this is a public registry, or you can even use a private one. We'll show you in a moment. And why do we need this? So for two purposes. The first one is we need to get this image. So this image is coming from the public registry of AWS. The public registry is basically a place where people store their images. You can store public images and you can store private images. In this case, because we are building our own custom AI agent, we want to store it in a private registry. To create your own registry, private one, you go to AWS ECR registry. It's free, by the way. You do create repository. And for this case of our example, you just put this name, and this one is the tag, so you don't put it. Once you created it, you can do view push commands. You can copy this one, and it will just log into your registry. Once you're logged into this registry, you will be able to do two things. First of all is to pull the image that we are using on the Docker file, and the second one is to push your own images, which we'll see in a moment why we want to do this. And now we want to build our image. So before you can even build your image, you need to install Docker on your machine. I'm using Docker Desktop. Every time that you run Docker build or any Docker command, you need to make sure that it's running. Let's break down the Docker build command. So what it's doing, it's giving us the tag. We give it a platform. Because I'm running on Mac OS and Lambda is running on different platform, we want to make sure that we build the image to be compatible for this platform. The F flag is for the path of our file, of our Docker file. And this dot is to say that we are working on this current directory. So after you fill the information in the build.sh, just run it. It's building the vector database. We logged into our ECR and it built our image successfully. If you go to your Docker desktop, you can see the tag that you put and everything and latest, and we created it 0 seconds ago. And if you can see also the images, I told you that this is the image that we are using on the base. So you see that here it's defining the environment variable as I just explained before. Okay, this is cool. Now we have an image that we can install on different environments, on AWS Lambda, on our own machine, and so on. So first thing, we want to make sure that it's actually working. So how to make it work is we gonna run this command docker run, and basically it's taking the image, running this on our environment. The terminology for this is it's turning into a container. So this flag is saying that once the container finished running, delete this. This port is mapping our port from the Docker image to our environment. So it will expose the 3030 port. This entry point is what's happening is when we run this command, it's gonna do Python and give it this command for this image that we defined on our build.sh, and it will also get the environment variables, so it has the API keys and everything. So if we go here, just run this one, it's building the image again because I mentioned here to build it whenever we run it again. And now we can see that we got the API, but now from our Docker machine, which is pretty cool. And also you can see here that the platform that I'm using is ARM64, but because we are gonna deploy to AWS, we wanna make sure that the platform is Linux AMD 64. And we can do the same tests we did before. Great, now it's working from our Docker. But the huge difference is that now it's not gonna just work on Docker, it's gonna also work on our AWS Lambda. So to deploy, this is what we are doing. You need to obviously create an AWS account, you need to create your ECR, which we already talked about, and we also need to push our Docker image. Okay, this is why we put the tag and everything to make sure that we can push it to our ECR. Now, before we deploy this, we need to note some things here. So there is a few adjustments we need to do when we deploy this to AWS. It's working on our machine, but now we need to do some adjustments. So before I did this video, I ran it locally on my machine. And what happened is I got an error from SQLite. It says that on the AWS Lambda image, it's outdated or it's not using the right one. So we need to adjust this. So I went to the Docker file and I did these following changes. I looked online a little bit and they say that you need to install this package. And also the library that is using SQLite is ChromaDB. So this is here, and this is another change we did here. So what's happening here is under the hood, it's using SQLite, and we want to make sure that it's updating the SQLite. And here what I did is, if it's running from the Docker image, update the SQLite. If not, we don't need to do this, and I just defined it on here, and I set it up on the Docker file. So I added these two commands, this one, and this will be true whenever we run from the image. And then it will also import this in our code. The next thing we need to understand is that if, for example, you want to read or write to this database again, I didn't support this in this one, but if you want to do this, you need to move your database to the temp folder. Only the temp folder has write and read access. And the next thing is, if we want to deploy this, we need to define an handler. So we need to understand a few things before we deploy to AWS Lambda. This is how you deploy. So the way AWS Lambda works is that this is the entry point of AWS Lambda. So whenever we call the Lambda, it's going to get two parameters, the event and the context. What we want to do is we want to take this handler and we want to connect it to our API. We can do this manually. We can go to the event, check if event equals /health, if event equals /blah blah blah, call our API. Or we can do a shortcut. The shortcut is we can use mangam. So mangam is this library, and we just define it like this. We send it the app, and it's gonna do the handler part all for us. So if we go inside this mangam, what you see is that this is like the definition of the Lambda, and it's just gonna route it to our API. So it's making our life easier. This is the first thing we need to do to prepare for deployment. Now next, if we follow the README file, we need to run the deploy.sh file. So let's go to the deploy.sh file. The first thing we do is we build the image as we did before, but now we also do Docker push. Docker push is just pushing the Docker based on the image. This is why we want in the image name to include our repository URL that is coming from the ECR, and we want to include the name of the image of the repository and the tag so we can keep track of the versions. We do push, and then it will be on the cloud. Why do we want to push it? because we need to install it on the serverless. If it's only in our machine, we cannot install it, right? And then we give it service name and we run SLS deploy. SLS deploy, we are using serverless framework, which is pretty handy because it's saving us all the time of deploying to AWS. So all we do is we define our YAML file and we call SLS deploy. If we want to remove, we change this to SLS remove and it will undeploy everything for us. Here it's just the service name. Here it's either this is the default or it will take it from the environment variables. This is why I define it here. Then we are defining the Python version and so on. And here we are exposing an API gateway. You have all sorts of options with AWS Lambda. In this case, we want to expose an API, right? So we give it the image that we just created. So this one is coming also from this one, and this one is coming from the build that we saw before. It will take the image and it will do the Docker run for us behind the scenes automatically. Here we define the events /proxy plus, and this essentially will allow us to do /health /call agent and use it as we used it locally. Now, if we go back to our Docker file, we see this command. When we deploy, what's happening is behind the scenes it's gonna do Docker run and it's gonna run this command. So we are just transferring the handler to the AWS Lambda, which this is what it's expecting. So each time it's getting an event context, it's gonna take this event context. So it's taking the handler from app.api.handler and it's just gonna receive all the events and context. So hopefully you got it. It can be a little bit confusing. Maybe replay this again and look at the documentation until it makes sense. So we just gonna copy this one. We're gonna run the deploy. It's again building the image to make sure it's the most updated one. It's pushing it to our ECR. This one is using the serverless, so it's deploying right now to AWS Lambda. Now we got this link. Let's do the health check. We got status OK, and there you have it. We have an API that can be used in the outside world in a scalable way. Now let's connect it to VoiceFlow. So let's talk a little bit about security. So what we did so far, while it's working, it's not so safe in production environments and it's great for development, but we need to do some enhancements here if we want to use it. Although this video is only for education and by no means don't use this in production, do your own research, but we can improve it a little bit. So what we are doing is we are just sending the .env file to our Docker. It means that our Docker contains all the API keys and all the secrets and everything, right? So if someone can get their hands on this Docker image, they can see our API keys. Although also we are creating private repository, registry, it's secure, but still it's not a best practice to just put your environment variables like this. So we are doing a few changes. First of all, what we want to do is we want to have some kind of a production environment or a way to identify between production where users are there and it's most secure and everything, and between our local app or development app. So on our config file, we are adding this isProd flag to let us know that we are in production. Now, if we go to the serverless YAML, only when we deploy to our serverless, to our AWS Lambda, this flag will be true. Okay, now what does it mean that this flag is true? It means the following thing. If we go back again to config, we added here another function. This function is using get AWS secrets, and what it will do is just reload automatically our variables to these variables if of course they exist in the parameters that we get back from this function. We define it in the same file, and here we also check that if we're in production, we want to take our secrets from a different place, not from our local folder, from a different service. In this case, there is many approaches to do this, but in this case, we are using SSM, which is another service from AWS. We'll see the interface in a moment. And all we do here is we just give it a path, and this will take all the parameters from this path that we look at it in a moment, and it will create a dictionary with the parameters that we get from the AWS SSM, and also it will load this to our environment variables. Now to set this up, we go to AWS, you can write your SSM, and it will give you Systems Manager. You scroll a little bit, you go to parameter store, and this is what you should see. So now you see that I have like 3 parameters here, and this is the 3 that you need to create. You just do create parameter, and you give it the path. The path is, in this case, it's the name of our project or the service. And here you want to do like OpenAI API key. You want to put your key in here, and you want to do like secure string, so it's encrypted. Once we do it for all our keys, we go back to the code, and the code is just gonna load it. So whenever we are in production, it's not gonna take it from the .env, or more precisely, because we are removing, we go into the Docker file, we remove this, we are not transferring the .env. So even if we do load .env, there will be nothing loaded because we are not creating this .env on our production machine. So once we created our parameters and now the application can access our secrets, the final stage is to go back to our serverless YAML where we deploy the Lambda. Here we give it the service name, and make sure that your parameter store is by the name of this. This is the path because we put it here and we also put it here. So the service name is also for the AWS secrets. And the final thing that we are doing here is we need to give the Lambda permissions to go and read from this service, from this SSM. And this is what we are doing here. And it's important to give it the resources. So we give it the resource itself, but also access to access the path inside this resource. And that's it. So to recap, we are just adding a new flag that is called isProd. It will only be true on the Lambda itself. When it's true, it's going to the config, and instead of taking it from the local .env, which will not exist on this case, it's going to take it from the AWS Lambda. Then it's gonna load it to our parameters, which is here, here, and here. Make sure that we also added here on the environment sample, we added AWS region. So this region is for your Docker file, your Docker registry, and your parameters, and where the AWS Lambda is gonna be deployed. And that's it. Now our application is a little bit more secured. So back to the README file, there is a few instructions here. We want to create a voice flow account. You want to create a new project. You want to create this workflow. You want to change the API endpoint to point to your AWS Lambda. And you want to embed it, copy paste to the index.html. Let's just do that. So we are going to create a new agent. We're going to call it lead gen YouTube. Get started. You're going to skip this one. Let's build the workflow. I'm going to edit the workflow. This one, you can give it a welcome message. For now, I'm just gonna delete this one. We're gonna click on the start. We're gonna do listen, capture. We're gonna do entire user reply. We're gonna make an API call. I'm gonna paste our newly created API. I'm gonna call agent, and I'm gonna send the query that we got from the user, which is in this case last utterance. And we also want to get the user ID. So we do end user ID equals user ID. Then we're gonna do capture response, and we're gonna put here the key response. And then we're gonna do create new variable, agent result, create variable. Once we do a success, we wanna print it back to the user. So we do message, and we just give it agent result without this. And also, once we get the response, we want to listen to new messages from the user. So we're just going to loop it back to the first event. We're going to click play. We're going to do hey, and we see how can I help you today? Fix pipe. Great. So it's asking all the sequence. Next thing we do, save this one. Make sure to click publish so it's the most updated one. And then go back. Then you can go to integration. You can put the name. So flow fix, you can give it some settings here. You can do upload image. So for the logo, you can give it the one I put in the assets, avatar as well, this one as well. You want to change the colors, you can put here like put black. Then you're going to copy this one. You're going to go to the index.html we created. You're going to paste this one in here. We're just going to run it with Chrome. And we see the little icon with the logo in here. So we click it. We say, I need to fix pipe. Okay, residential, let's say commercial. Okay, the price is 300. And then it's asking me, would you like to submit a service request? Yes. Okay, they need a name. I'm David, and this is my details. And it's also asking to confirm. And that's it. It saved the request. Let's take a look at our Airtable, and we see David, and we see all the details. Pretty cool. And that's it for this video. We see how we took our AI agent from the previous video, we put on top of it an API, we built a Docker image, we then deployed this to AWS Lambda, then we did some security, and then we embedded it on our website, and now we have a chatbot that can handle user queries 24/7 for us, save it in our CRM. And of course, we can add more functionality, we can do all sorts of other cool features. And I try to cover everything in this video, but of course, in real life, there is more details, there is more nuances, or when you are doing your projects or for clients, make sure you do your own research. Now, if this video was useful for you, click the like button below. And also, the plan for the next videos is one of these ones. And if you have more ideas and you want something to see next, make sure that you comment it below. So the next videos are gonna be around integrations, Telegram, WhatsApp, or something else, upgrading local database to remote database using Postgres and other tools, how to build a YouTube QA chatbot that you can give it a video, then you can ask questions and it will give you timestamps and specific things about the video, how to build agents with low code and no code. So let me know which videos you wanna see and make sure to subscribe so you get notified when these videos are coming out. And finally, if you want to learn specifically how to build AI agents for your business, because as I said, this video is kind of a template and there is specific use cases, specific things to your business, let's connect on LinkedIn and I can guide you through what's the best solutions for your use case. Thank you for watching and I'll see you in the next one. Bye.